Are we live? We are live. Okay, then welcome to this second talk of this series with Eclipse. The second talk will be mainly about domain-specific languages. So we first need to talk a little bit what domain-specific languages actually are. So you are used to, like on the bottom, what you're currently using or what you know of is assembly. On top of assembly, you have programming languages like, let's just say C. And even below assembly, there's usually like, let's just use CRX 90. There's usually the bytecode, the machine instructions. CRX 90 is an opcode for x86, but it doesn't really matter. So that's what you're currently looking at. And somebody might come up with the idea to place an initial layer on top of that. So let's just do it. What would you put in there? I mean, it's basically up to you. For example, SQL can be considered a domain-specific language. SQL or SQL is the query language for SQL, and you can use it to query information out of databases. And the difference between like a language that sits here on top and below is basically most of the languages that are like a level B above our usually programming languages, they are usually not Turing complete. So again, what is Turing complete? Turing completeness basically just means that we can simulate a Turing machine within our programming languages or within our programming language. What is the benefit of doing that? We can prove that our language is Turing complete, and therefore we have the same model of computation. And currently the Turing completeness is like the biggest model of computation that we have, the mightiest. So usually these languages that are on top of our usual layout, they are not Turing complete most of the time. An additional example for domain-specific language would be, for example, there it is. HTML might be hard to read. HTML is a markup language, so it specifies it's like markup to text, and the markup will define how the text is going to be how the text is going to look like. So just maybe just a quick peek into an HTML file. I should have some HTML files somewhere. There I have an HTML file. So this is how an HTML file looks like. It shares certain similarities to XML. So, but as you can see, it doesn't look like that you have instructions, stuff like that. So you can basically program with it, but it's still a language. It's a markup language, and it's tailored towards the domain. And the domain it's being tailored to is the World Wide Web. Everyone in the World Wide Web uses HTML for running websites, and in the background even CSS and JavaScript and stuff like that. But I don't want to talk about that. So we've seen two examples so far for domain-specific languages, HTML and SQL. There are even many more other domain-specific languages, like you name it. I mean, there are plenty out there. So what are the benefits of such a domain-specific language? Well, we have a language that's tailored towards the domain. What's the benefit of doing it like that? Okay, let's assume a use case where we, for example, we have three devices. One is just say Android, one is iOS, and one is Microsoft Windows. And we as a developer don't want to write the code 3 times for that. But the majority of the code is different. But so we have to write a certain base framework for all of those 3. But maybe we have a server somewhere. Just call it on top, server. Now maybe all of our applications or apps want to talk to the server, and well, unfortunately, the code for doing that on Android, on iOS, and on Windows looks slightly different. It's like it might have certain similarities, but it looks a little different. So we can go ahead create our own custom DSL in the middle. And the custom DSL will basically specify what information we are going to transmit over the wire. Like, for example, we are allowed to make a request get user or something, and it will specify the custom DSL domain specific language will specify, okay, the method get user will needs like an argument like user ID something and returns like a string, maybe the username or something. And by defining the custom domain specific language, we end up with our own language we can use for translating all the code to the other languages. So what do I mean by that? Before digging deeper, I want to give you an example of how I do it in my projects. So slightly different example, similar but slightly different. I wrote up one of my domain-specific language that I wrote is used for preferences. So preferences, like a database or something, can also be considered preferences, or just basic attributes, key value stores. They are like a foundation of every program that you have, of every application. You need to store application settings or certain data lists or something somewhere, and that's why preferences are like they occur in every project. So that's why I came up with the idea of specifying a domain-specific language for those. So let's have a look at this is Android. Here's my preferences, and I have this file. So this is, for example, this is my domain-specific language that generates the code for the preferences within Android and also the other environment that I'm using, but you will be seeing that in a second. I have a general section here, and I completely designed that myself. You can specify a domain-specific language however you want it, and I specify it to have an output. So the output will be Android. The type is attribute, so it's just like a key value basically with predefined keys. That's Java specific that I have to have a package, and the preference have a name. That's the fuel type, and I have one attribute which name is str name. Its default type is str, and I'm giving it a default value which is name super. And this few lines will generate 4 files for me, which are these. And if I have a look into them, you will be seeing that I specified the attribute name. So I'll have set str name, get str name, and clear str name, and all of this is defined. I defined the DSL. And by defining this all in the background, there will be a generator for generating the code, which you see here. And for example, also the default value will appear. And you can extend it. For example, I know that station is a database. Station is more than one element. It's a list, so it's a little bit more code. And for example, this is the table layout inside of the database, and everything is being generated by these few lines. I write these few lines, start up my generator. The generator will pass my domain-specific language, will interpret it, and will come up with the code for what you've just seen. So I only have to write these few lines of code, and all these files here will be generated. So to see this in practice, I'm just going to delete these, because they are all generated. So they are all gone, and you can see all the errors popping up. I'm now going to run my generator that generates the source files again from my domain-specific language. That is that one. It takes a while because it's pretty big. Just give it a second. Code generation finished. I'll press F5 here, and all my code is back, and all the errors are gone. So now I have this domain-specific language that I came up with, and I can use all these things in other projects. You can see that I have plenty of projects in here, and all of them use this domain-specific language. So I don't have to care about implementing the preference code anymore. I just write what attributes I'm looking for, specify the type, whether it's a database, it's an attribute list, or attributes, or it's just a list. And then it will generate a code for me. And it's just write once and reuse. And I don't have to care about bugs anymore. If I have a bug, I can just modify my generator, so it generates the new source code with the fixed bug, and I can regenerate all my code, and the bug is fixed everywhere. That's a pretty nice feature. So what about C++ in here? This is a C++ environment, and you can see that I am having generated files again. This time here the preference folder is also generated, so it looks similar. This is a key value store, I think. Yeah, it's like it also has a gets the name, sets the name, clears the name. It also has a, this time it's a list or a database, but you can see it's quite a lot of code. So, but the thing is, if I look at the domain-specific language, it's still the same. The only difference is that I'm now outputting the target is now Qt. So it's C and C++ and Qt is on top. So it generates Qt code, and the same here. I can delete all these files because they are all generated. And now I can start my generator. Takes quite a few seconds. And now I press F5 again, and all the code is back up. So I now have one domain-specific language for C and C++. And let me tell you, I also have it for JavaScript, but we'll just skip it for a second. All right. So the question now is, how do you come up with domain-specific language? How can you design your own domain-specific language? That's what I want to teach to you. And the way I'm teaching it to you is with an Eclipse environment that is called Xtext. And you can, if you Google download Eclipse, you will end up on the site here. You have several projects, and you can download Eclipse IDE for Java and DSL developers, domain-specific language developers. You can download it, and there is Xtext in there. And Xtext is the environment that I will be using. So I have it downloaded here. I'll just run it. It will ask me for a workspace. I'll just give it an empty one. So you'll see how it looks like when you start it up. It looks like exactly like you used to with the welcome screen. You hide the welcome screen. We have all kinds of stuff that we don't need. Let's just hide it for a second so we don't get distracted by that. And now we create a new project. And in the previous session, I showed you how to create C projects, Java projects. I want to create a Xtext project now. So I just selected Other. And now I go to Xtext and select Xtext project. And is it? Yeah. OK, now I can give it a project name. And let's just call it DSL. And I can give the language name. Let's call it. I'll just give that test, and I'll just give that com.correct.dsl. By the way, the DSL in the back has to be capitalized. That's a thing from Xtext, but I think it will warn you. Yeah, it warns you if you don't do that. OK, for the extensions. How are domain-specific languages, in the way we are creating them, distinct? And you might have already noticed it. They are being distinct by the ending. So if you look at the preference, for example, might have the ending prefgen. Oh no, I don't want to open it. And there are other domain-specific languages that I used. For example, this is a language-generated file. So the distinction of which this DSL is within a file is being made by the extension, and we'll be calling it just DSL. It doesn't matter much because it's just an example. We'll hit finish, and it will generate us 4 projects now in a second. Here we are, our 4 projects. Might be a little bit overwhelming at the first place, but we will get used to it if you use it more often. OK, what can we do now? OK, or in other words, what are we currently seeing here? This is basically a grammar like you're used to it. I mean, usually the grammar that we are looking at usually looks a little different. Usually you have like a starting symbol, goes over to A, or B, and then A goes over to something, and B goes over to something. But basically what you're seeing here, is very similar, except that Let me show it to you how you are used to it. You are used to something like greetings and then model again, or just greeting. This would resolve the problem. Or just epsilon because we had star, but I will say something about that in a second. So it just looks a little different. That's how we're looking at it. And the star, by the way, it's we are using an extended Backus-Naur form here. And since extended Backus-Naur forms are not really specified, I guess it fits well under the term of extended Backus-Naur forms. And the star just means 0 or more occurrences of greeting. And greeting is specified here. We expect a hello, then we expect a terminal ID, and then we expect an exclamation mark. And basically this and this is just some information that we don't necessarily need, but we'll be using it. So what is this greetings plus equals and the name equals? It's just names for the variables, how they are going to look like in the abstract syntax tree. So once we have specified our grammar and we are parsing it, and the parser will generate an abstract syntax tree, and we can traverse through the abstract syntax tree by using those predefined names that defined in the grammar. That's an additional extension. And you can also, this is a very common extension, times and also plus, and the question mark. The question mark is an optional. So let's just, hello, let's just specify there, question mark, hello there, question mark. Yep. Oh, no, that. And then this is it might appear in our text that we are parsing, or it doesn't. It's optional. By the way, to get you all up to speed, I'm not 100% sure whether you're still familiar with the process of parsers and scanners and all that stuff. This is just a simplified version. This is not how it looks like in real life, but you have a lexer, or also sometimes called parser. No, it's not called parser. It's called scanner. Sorry for that. And then we have a parser, and then we have our abstract syntax tree, and there's the input. So the parser uses the grammar and creates the abstract syntax tree. But just to get you going again, the lexer will generate tokens out of the input, and the tokens will be used by the parser. So for example, the ID here is a token. And how does ID look like? It's specified in our terminals here that we are importing. So let's just open the declaration of ID, and you'll be seeing that it might start with a circumflex, or how is it called again in the US? Caret. The caret. And then it might start with A to Z in lowercase or in uppercase or an underscore. And then there comes an arbitrary numbers of smaller, lowercase, uppercase, A to Z's, or numbers, or an underscore. And by the way, this is a regular expression. It's a little extension of regular expression, so the error here usually isn't present in regular expressions, but they extended it here. So the tokens are defined through regular expressions. So we will be starting the generating process by having Alexa creating all the tokens. Then our parser will use our grammar and form an abstract syntax tree out of the input stream of the tokens. This is our tool chain. So let's just start that. Okay. When we have specified the grammar, we have to generate all the parsing code and all the class structure, and we'll be doing this by opening our test project here, and here's our DSL, our domain-specific language. We'll just right-click on it, right-click, and run as generate xtext artifacts. Now a command line appears, and it will ask us to download a parser, the NTLR parser. The Xtext by default has this internal parser, but I not recommend using that one. I recommend just downloading. Yes, I want to download the NTLR parser. The reason why they're not including the parser right away is probably because of licensing. And now we're downloading the parser for you. And we'll be waiting just a second. Or more. And you just saw that a few certain things popped out on the left side. And it says done. That's nice. Okay. You can. Okay, let's just run it. The nice thing about Xtext, it fully integrates into the Eclipse environment. So I can already go ahead and say, run my project as an Eclipse application. Might also take a while. And in my new Eclipse instance, I can use my DSL that I just created, or the default one that they create for me. So I can generate a new project in here. I'll just create just a general project with nothing in it. Test, and I can create a new file which has my DSL ending, test.dsl. You'll be seeing a prompt now, asking you to what?
I think you titled yours DLS.
Oh, thank you. That would have caused big issues. I call it DLS. Thank you. I have unsafe changes. No. Hopefully now it will prompt us. We will see DLS. No, it didn't. It probably didn't think of that. Okay, new file test.dls. Yeah, now it's the prompt. Do you want the Xtext nature to be added to your project? And we'll say yes, because that way the DSL that we wrote is integrated into the project, and you can use it here now. So far no errors appeared. Why are no errors appearing? Because the grammar that we specified, the starting entrance is model, and nothing can happen. Like if you have 0 occurrence of greeting, it's also valid, so that's a valid DSL file already. If you start here and type hello, it will complain that something is wrong with our rule, with our grammar, because if we have a greeting, it expects a hello, then expects something that looks like an ID, and then expects an exclamation mark. Additionally, optional in there. So let's just say hello and hello Simon, and still errors because we forgot the exclamation mark, and it works. Now no errors. And you can see, hopefully it's visible. Might be a little bit small. Is it font size, by the way, big enough for everyone? All right. You can save it, and you can see that the hello, for example, and the exclamation mark, they are highlighted. They have a little different color because they are specified in the grammar, and the ID is just a token. So the Simon here is the ID, and it's not like not highlighted. By the way, you can see that Simon also appears in our outline, which is pretty nice. So we had the optional hello there. So here we go, also very valid. And you also have code completion if I type hello th, and if I hit the control and spacebar, it will give me options, and I want to have that there. So it has code completion, which is nice. Let's just close it for a second. So how are we able to generate code out of that? We have a generator in here, and this is basically it also has a small example in there. I'll just uncomment that for a second. Yep. Okay, it wants us to import something. We have to import the greeting. Small hiccup here. Here we go. Import the greeting. Here we go, no errors anymore. If we do the same again, we run our domain-specific language as an Eclipse application. And And I also add, hello, who wants to be a volunteer? Parker is going to be a volunteer. Hello, Parker. I say save. At first glance, nothing happened, but if I open test, there is a greetings.txt. People to greet Simon and Parker. So I generated this file out of that. And we'll be having a look at how it's being done in a second. Let's just close it again. Just want to give you a full overview first before I go into details. By the way, the language that is being used here is extend. It's an extension to Java, so it has some handy extension that you will be seeing later. Let's just use validation as the next step. I'll uncomment that, and I'll be showing you what this is in a second. Import the missing things. I didn't call it my DSL package. I did call it DSL. No, how did I call it? It's somewhere in here. I just called DSL package, apparently. Now I should be able to import that. Come on, you want to do it? Here you go. Import from, doesn't matter. All right, save again. Run as CAPS application. It always takes quite a while until the second instance started. And now nothing changed, and that's how I expected it to be, because this is the format that we decided. What if I write Parker without a capital P? Well, person names usually start with a capital letter. So it now complains that this doesn't start with a capital letter. Name should start with a capital. This is being validated through the code that I just, the code that I just uncommented here. It basically checks whether the greeting name character 0 is uppercase. If it's not, it submits. It raises a warning. It's basically just like you've seen it with Java, for example, or with C++ before, that if you do something that might be wrong or is a little bit off, it generates a warning. And what you've also seen, especially with Java, is like the quick fixes, that you can hover over it and see that you can generate quick fixes. And I think it should be in here, yeah. Where is it? There it is, quick fix. Again, this test project comes with a quick fix already presented for this case. I'm just going to uncomment it. By the way, it should be DSL validator. And I didn't uncomment it. Why? No, just uncomment it. Okay. It's a fix for the invalid name warning. And what it will be doing, it will be given the name, and it will replace in our document the position where the name starts, and it will replace one character, and it will replace it with the same character to uppercase. We don't have to care about the syntax. The details are not that important. I want to give you a big picture. So now if we run it, we'll still be seeing the warning that Parker is not capitalized, but now we can hover over it and say capitalized name, and then if we hit on it, it will capitalize it for us, which is pretty nice. Okay, also usually with Eclipse you have the formatting rules. You can also specify this within your domain-specific language. There is something called formatter, and you can specify formatting rules in there, but I want to skip that topic because it's not that interesting right now. Okay, so we talked about generating, we talked about checking, validating certain semantics. We talked about how we can cope with semantic errors with quick fixes. I gave you the information that you can write formatting rules. There's also, here's the test project. You can generate test cases, and you can test things like you can give the parser a specific domain-specific language file and can check whether the syntax tree that will be, the abstract syntax tree that will be generated matches a certain expectation. So you can integrate test code that tests your generator and your domain-specific language right away in here. But I also want to skip that. So now let's just remove that. I'm going to clean it a little bit. That's the validator. I also want to clean the quick fix, because what I want to do now is I want to work with my own domain-specific language. I want to create my own one for a second, so I'm removing that. We'll be leaving that for a second. So what can we do with grammar? We can specify, for example, okay, before I'm doing that, I might give you a little bit more information about the capabilities of the parser. What if I have a left recursion, left recur? A left recursion starts with itself, left recur, and then has something. Did I left recur? Okay, now it works. Well, it only works because I didn't use it. Let's use it, left recur. And it doesn't work. Change to misspelling again. Here we get an error. The rule left recursion is left recursive. To remind you again, what is left recursion? You can see that here left recur has a production rule that goes over to itself, and it would go over endlessly. That's hard for a parser, it's not impossible. I think that NTLR version 4 is able to deal with left recursion, but Xtext is using version 3. Probably because version 4 might be a proprietary license. Anyway, you see that left recursion is not possible in here. There's also a common problem which is called dangling else. What is the dangling else problem? Basically, if we have something like if condition 1, then if condition 2, then this, by the way, is not a grammar. I'm just placing it in here because it's easy. Then we have like a foo, else, bar. How do we know? I should probably insert it into a different editor. Maybe just insert it somewhere else that we don't have all the arrows. And can I zoom a little bit? Here we go. How do we know that else belongs to this if and not that if? I mean, I indented it that it might belong to this, but the grammar can't necessarily tell. It could also be that. I mean, in between this are just white spaces. And with our grammar, we usually don't care about white spaces. I mean, there are programming languages like Python that do, but most of the time, we don't care about white spaces. So that's called the dangling else problem, and let's just give you an example of a grammar that implements an if-else condition. So we have an if, or how are we calling it? Let's call it, it's called if. Might not be the best name. And we have either like a terminal ID, or an if might be an if, or an if. Then it might be an expression, and let the expression be let's just also be an ID. Let's keep it simple. Then we have an expression again. Let's also use ID again. Then we have an optional else. Elses are not always common. And if we have an else, we also want to have an additional expression. Oh, that's... And we can have ifs inside of the if. So let's just do it that way. Let's just call it expression so it makes more sense. Expression. So expression can be just an terminal ID, or it can be an if followed by an ID, followed by a then, followed by an expression again. An expression can be an if again or an ID, and optional an else at the end. This should generate my dangling else problem, at least I hope so. Let's just try it out. Expression. Okay, it says non-empty. But that's not the problem that I expect. Let's just generate the Xtext artifacts again. Here we go. Right-click on the Xtext file, and say generate X text artifacts. And hopefully I'll be seeing 2 red lines in there, maybe 3 red lines. No? Why are there no red lines? Let's just use it that way. Expression. Is expression predefined maybe? Parser rule. Oh, I just forgot the question mark, that's why. Small question mark, big impact. Run as, generate X text artifacts. Hopefully now I'll be seeing 2 red lines. Here we go. It warned you that we have like a rule with alternatives. That's the dangling else problem. So we'll also catch something like that. So now that we have gained some insight into the capabilities of our parser, let's just specify our own language. I showed you the example of the pref generation domain-specific language, and it had a general section and it had attributes. And I'm just going to do it here. And the general section had an output. We want to generate an output for some certain target, and let's just specify a target could either be Android. Oh, let's just be basic. Java or C++. And then we have maybe a type, like whether it's an attribute list or just attributes or a database. So we have a type. So a type could be either attributes or maybe a database. And then let's just we just give it a name. We should give it a name. Name. And the name is just a string. And that's it for the general section. Now we have to come up with the attributes. Attribute, and I think I have a misspelling up here. And an attribute is, oh yeah, we should also give the general section some embedding. We should embed it in a section maybe which is called general. And we be using parentheses, and everything in the parentheses will be this. It's just looks a little bit better. I mean, it's not necessary to do it that way, but we'll be having this general section then, and then on the other side we'll be having attribute sections. And again, we're having parentheses. We are expecting parentheses, and then in the attributes we have a name again for the attribute. And the name will be a string. Then we have a type. And the type will be, let's say, either a string or an int. And then we have some default value, and let's say the default will be, we'll specify the default value within a string. Okay, that's how it should work. Okay, you will be seeing where we will be using the attributes and name and this name and the default in a second. We also have to give this output. We have to store it somewhere so we can access it later. But you will be seeing where we'll be accessing this in a second. Let's just save it for a second and see whether it still generates or whether it's still a valid grammar rule, well, it's still a valid grammar, and hopefully it will be. Yes, it is, and I can go ahead again. Now it complains, by the way, in here because all these things are no longer present. I'm just going to remove them, and we will be doing this later. Greetings doesn't exist anymore. Also probably here, yeah, greetings doesn't exist anymore. Now let's just run it as an Eclipse application again. And I'm maximizing this for a second, placing it up here, placing this up here. So in our DLS file, if we save it now, it will complain because now it expects at least a general section. So we know that a general section has a general, parentheses has an output, and the output is either two things, either Java or C++, let's say Java. Then we have a type. The type, let's say we make it simple, attributes. And then we have a name, we will give it a name, and the name, this is a test. And now it works perfectly fine. We can have this. We don't expect attributes because we have a star in here and not a plus. So let's just make an attribute. The name of the attribute will be a string. And the type of a string is, of course, a string. And the default value will be this. Can we do it like that? Yeah. Okay, let me just replace it for you can understand it better. The default value for a string is an empty string, and I embedded it into a second string, so that's why it looks like that. So this is the string there with the single quotes that we have specified in our grammar, and the string inside is the default value. Might look a little strange. And just to be complete, we'll have a string, an attribute, which is not a string, but it's an integer. And then the default value, this time we don't need double quotes, default value 0. By the way, just a few hints. Why did I write it that way, not that way? And why did I write it that way and not that way? It's just to be, my grammar wants to be a little less strict. So if I would have written it that way, it would have expected it here in that format. So something like this would have been invalid, and something like this would have been invalid. That's why I separated it into several terminals. Anyway, let's go back here. If I save it, nothing will happen because we didn't write a generator. Before I write the generator, I want to give you one last hint about the grammar. Because you can have references inside the grammar, which is pretty nice. So let's just specify in the general section we will have a summary. It doesn't make sense, but it emphasizes it, what I want to teach you. And then a summary is basically an array, and we'll denote arrays with brackets. And in here I want to have the summary of attributes. So it will go like, remember that type equals, no, it just should be attribute. Name has to be unique. Why doesn't it want to work? Double check it. Does it has to be type equals? Okay. Let's just remove that for a second. I'll get back to that later. And then focus on the generator. Okay. Now we want to generate code for our domain-specific language. Namely, we have Java or C++ code. So in our generator, the resource is basically our abstract syntax tree. So the first thing that we have to do is getting access to the abstract syntax tree, and we have a model in there. So our model, and we probably have to include model. Yeah, import model. We have a model, and our model is specified in the resources. And this might look a little strange, but it's just syntax sugar. I just write it for a second and no, it's not brackets. I want to filter for model, and then I want to have the head. So all contents are all the nodes within our abstract syntax tree. I want to get just the model nodes. That's why I use filter, and we'll return a list of all models. But since we'll only have one model, models, by the way, this here, I would just want to have the head of that. So I'll get one model back, namely the model up top here. And I can now use that model to generate languages. So let's just say we don't want to name the file with greetings anymore. We just want to have model dot. How did we call it? Did we call it general, or did we give it a name at all? We might forgot to give it a name. We might have forgotten that. Yeah, we forgot to give general a name. Sorry for that. General equals. But now you're seeing it by we're using these names, namely in the generator, to go over the tree. I have to, oh, no. I have to regenerate my artifacts, run as artifacts, yes, saving. And now I should be able to access the general branch within my generator. General, yeah, here we go. And in general, we have specified the name. So now I want to give the file, the txt file, and now it's a txt file, the name of which we specified in the DSL. So we specified a name here, and the name that will be generated will have the same name. And also, we should pay attention for the ending, because we have C. Did we have C or C++? I think we have C. Did we have C? Java and C++, I think. So we should have a condition here. If model.general.output equals oh, that might be hard to access. I guess let's just see that. Okay, how do I access? It returns a string. Might be this then. All right. Oh, and since we are in Java, we should use this. Or it's like extend, but it's similar to Java, so we should use equals instead. Luckily, we caught that. So now we are using a Java ending. And else if it is, by the way, semicolons are optional, but I like to make them in here in extend. I think we called it C++. Yeah, we called it C++. We will have a CPP ending. And now we want to generate the code specific to C++ and specific to Java. And the way we will be doing this is by specifying a new function. We will be calling it def static. We want to return a string, and then we want to generate Java code. We will be passing the model. And that should be it. Not string, and then the same for C++. CPP, oh, not umlauts. And now we can call these in here. So I can call dsl.generator dot compile. No, I think I have to save it first before it appears in the autocompletion. Oh, it's called generate Java, passing the model. And for the C++, we will be using the other function, generate CPP. To keep this lesson short, I'm just going to populate the generate Java. We'll be leaving the CPP blank for now. Now, this is something really convenient with xtext and extend. If you make 3 quotes, you have a string block. And this string block will automatically be returned through this function. So we will be returning our string. You don't necessarily have to state return this. It works without. Now this is what will be returned. So for example, in Java we usually have something like public, class, and then we have a preference, and we should give the preference a name. So we will be doing this in a second. And then in here we will have a bunch of attributes, constructors, and functions. So how are we going to oh yeah, let's first about these 3 quotes. These 3 quotes, it's like a comment block, but it's a string block. It's a smart string block because you can see, let's just do something here, test. Everything that is like gray, this will be printed afterwards. So it doesn't print the tabs in the first place. So it's like it knows that you are starting in here in this row. It's convenient because otherwise you would have to write it that way and that look pretty strange. So they implemented this text block such that it starts at the leftmost column is the column of where your first character is. So only the gray stuff will be printed, which is pretty nice. Okay, how can I insert something in here? I mean, usually with C++ and Java, you're used to something like that, like concatenating strings by having a variable plus something, or with C++ with the I don't know what they call in English, these ones here. How are they called? Nobody knows? The arrows, okay, we will call them arrows, with arrows. And in Java with plus. And here we can do it the same. We can concatenate like single strings, but such a text block is way more convenient. And I'll be using this. What is that? It looks strange. How can you produce something like that on the keyboard? Well, there's a shortcut for that. You just press Control and spacebar. So I want to replace the to-do, and I want to give it the name of that we specified in our language. So here we are specifying name test. I want to replace the to-do with test. How am I doing that? With these quotes, and these are called French quotes. I think they are also called Spanish quotation marks sometimes, or Latin quotation marks. I think the general quote is angle quote or something, but I call them French quotes. And in here we can access the model.general.name, and I want to convert the first upper. Now the first it will insert the name in this position here, but it will convert the first letter to uppercase. So that will be preference test, and the test will have a capital T, and then I can specify other things in here. Just to make sure that everything works so far, we will be running it again. Just close that for a second. Yeah. Run as Eclipse application. And now if I change something and save something, it should generate the files for me. Okay, it didn't, and I have an idea why it did. Oh, it did. Oh, it did. I'm surprised it did. It worked on the first try. A day to celebrate this. Okay, this is what we expected. Public class preference test. It's pretty nice. So let's just go over it and give the class some attributes. So you see that, that's not the one. You see that our example has an attribute, 2 attributes, a string and an integer, and they will be looking like that. Private string, a string equals that. No. Private int an integer equals that. That should appear afterwards in here. Well, how are we doing this? We have to iterate somehow over the attributes. And how are we going to iterate over something? Or how are we going to insert something? You got it, French quotes for. And we'll be using an iterator for that. So the handy version of that is we'll be giving it a name, the attribute, and we are looking for attributes within model.attributes. And it will complain in the end, probably because it doesn't have an end4. End4? Yeah, it does. So how does it start? We start with private. Oh god, my spelling is off. Private, because one have put private to the class. Then we have the data type. It's either string or integer. And then we have the name. And then we have the default value. Well, let's just make the if outside. If let's start attribute dot type. Type that is equals string. Then we have something, and we have an end if or elif. How's it called again? Else if. And then we should have an end if. And this should probably, and it probably expects attribute.type equals, just have to spell attribute correct, equals, and also equals correct, equals C++. Okay, now we have, let's just remove that. Now we have a for loop, and depending on whether the attribute that we are currently iterating on is a string or C++, it doesn't make any sense. Int, or as an int, we'll either enter this branch or this branch. So for this branch, we will be generating a private string, and for this branch, we'll be generate a private integer. And the name of this is predefined with the predefined name attribute.name. And also here, attribute.name. And we gave it default values like attribute.name, no, dot default. Is default attribute dot default, here we go. Oh, and the caret, I learned the word. The caret, by the way, is probably inserted because default is probably also used internally somewhere. So we call the default value here default, and default might be used internally otherwise in another position, so they automatically insert the caret here. And I'm just going to leave it. Just remove it. And it complains because I accidentally removed the French quote. Let's just start our instance here again, run as Eclipse application. Save it. And our test.java has two attributes. Here we go. That's what we defined. And you can keep going like that. Generate the constructor, generate getters and setters and all these things. And usually the way you do it, you specify your code first completely, you write it in Java or C++, test it, and if you're sure that it works, you copy and paste it into such a block, and then you replace all the generic stuff like the name, the variable types, with all those annotations here. And in the end, you will end up with your own generator for your own domain-specific language. And that's it for this small introduction. I'm now open for any questions. If there are any. Parker, yes, please.
You asked for a reminder about lab.
Oh, the lab, we will be doing it afterwards. Thank you. Joel?
So the main benefit is you do this work up front.
Yeah.
Later on, you don't have to
exactly
worry about doing it for each language.
And you saw that I gave the introduction example with my ended project and also the C++ projects. I spent a little bit more time once to generate the DSL, but you saw that it's really quick. I just wrote my own DSL in like maybe 40 minutes or something. And you just copy and paste the code. You have to spend a little bit more effort to make it general, but then you can just export it and then use it wherever you want it for different projects. So you're having your upfront cost a little higher, but in the end you will be saving a lot of time. And one major benefit I think is if you have an extension to one of your, if you, for example, have you want to have like private or public void clear. Maybe you will end up with a situation where you want to have a clear method that clears all the values to the default value. And if you want to introduce something like that into your own program, you have to go over all the source files and all the projects and implement it everywhere. And it's error prone because in the clear function you have to clear all the attributes. And that way you don't have to even care about it. I mean, you specify the attributes in your domain specific language and the clear code will be generated for you. You won't have the problem of maybe forgetting, clearing a value or setting it to the appropriate default value, because maybe I have a default value set up here and I'm accidentally, because I was tired and I copy and paste incorrectly, I'm just setting a different default value by accident. And that way you're solving all these problems just by generating. And that way you can you change your generator a little bit, and then you just regenerate all your code. And it's always so pleasing when you sit there, you have like a small bug or an extension, you change your DSL and it takes like 10 minutes at most, because you're just inserting it once. And then yeah, and then you just go over all your generators, start all of them, and then they will generate like 10,000 lines of code in all the different projects, and you don't even care about it. And it's like, and all this code that you're generating is usually code that you don't have to look at it again. You're just using it. So I'm using my preference code in other sections of my code, but I don't even care about how the preference code looks like internally, because I know I have this interface to it. It has this attributes. If I want to change an attribute, I just open the DSL, change it there. I don't even look at it anymore, which is especially convenient, for example, for the database. So let's just have a look at the database again. Database code is sometimes a little bit tricky. There we go. Because you have all these, this is SQL, so I'm using a domain-specific language within my generator, which is nice. And all this stuff here, the queries, this is an insert into, this is a create table. I don't even have to care about this anymore. I thought about it once when I created it, and now I'm just using it.
Is the debugging process easier or about the same?
It's the same, because you're generating C++ code, Java code, whatever. And if you're not trusting your code, are we back online or?
No, we've been online. Here you go.
All right, thank you. If you have a bug, assuming that you're a bug, you're just debugging your C code or C++ code, and then you see, okay, I have a bug in my code, in my skeleton code. I just go back into the generator, fix the bug there, and regenerate it for all projects, and the bug will be fixed everywhere. Parker, I think you had a question, do you?
Yeah. To what extent does this require that the languages be somewhat similar structure? I mean, could you do this with like Haskell?
Absolutely. Okay. I could generate not even. I mean, it might be a little bit tricky if you generate like I'm just using imperative programming with Java and C++, but the Haskell code would look similar. Problem with Haskell input and output, and Prolog is probably also similar. But it's up to you what you are doing with it. And if you think about it like, okay, I have an object that has attributes, values, and you just have to think in a different paradigm in Haskell. But you will, in the end, generating a string, a big text file, and the text file will look differently. But you will still see like there's like a small area for storing. Okay, you can store in functional programming languages. You don't have variables there, but this shares certain similarities, so you can translate it to different languages. One limitation, though, is like there are domain-specific languages that are graphical, like drag and drop graphical user interface editors. I showed you a few screenshots of Eclipse versions of like Codesys or Wireframe Sketcher or IBM Rational Rhapsody, and there you have like graphical user interfaces where you like drag and drop objects together and like make connections in between them. With Xtext, you can't do that because we are specifying grammar in some forms of text. So our domain-specific language will always be text files and not graphic files. I mean, there might be like an additional step in between. You have a graphic user interface editor that will generate maybe XML, and then you will be passing the XML in Xtext, and you'll be able to generate language, other stuff again. That will work. Questions? A little bit overwhelming, I don't know. All right.
It's a little bit at this point, but the big overview, it seems like it would be useful.
Okay, then let's just let me just end the section by saying there are different tools available. I just use extend because it's simple. It gives you a good thing. It just took an hour to come up with all these things. There are also tools available like YAC, yet another compiler, or Java CC, and all these stuff. They're like other compilers. But I mean, I looked at them like 4 or 5 years ago, the last time I've looked at them, so it might be different nowadays. But back then it was really hacky. You had to dug through all this documentation to figure out how to come up with something like that. And I mean, this is really integrated. All the syntax highlighting, you already get that. All the code completion, you already get that. I mean, I don't really use it most of the time, but if you have a bigger domain-specific language, it would be nice. And the thing that I wanted to show you, but I end up not showing it to you, is like you can have grammars which have references. Like if you have attributes and you're using it somewhere else, you can specify the grammar in that way that it will only if you want to reference attributes somewhere else, that will only work if the attributes have been predefined somewhere else. And that's pretty handy to do something like that, because it's not standard in the Bacchus Noah form that you have references within the grammar. But since we are producing an abstract syntax tree, they will just be using the reference in the tree, and therefore generating more like a mesh, a graph, and not a tree anymore, but still the same idea. So to sum it all up, since there are no questions anymore, we looked at what domain-specific languages are, why they are useful. We had a look at how to generate them by specifying a grammar, specifying a generator. We also had a look into like validation, quick fixes, test cases, formatting tools, but that's just sugar. The interesting part is create a grammar, and then use the parse tree, abstract syntax tree, however you call it, and generating the output for different projects or different programs. With that being said, thank you for listening to this talk, and have a nice day. Huh?
Encore.
Encore?
Oh, it means do it again.
Do it again.